So if I have 5x cubed plus 10x squared, that's a 10, minus 6x plus 14. So y equals this. So dy dx, so we remember all this? How do I differentiate the first term? 15x squared. Remember, you bring this number down, multiply it, and then subtract by 1. 20x minus 6. That's it. Okay, so that is my derived function. Let's look at something. So what if I say y equals x to the power of -4? What is dy dx? The power of what? I have to add 1 to the power, right? So adding 1, I bring this down and multiply it by 1. So I've got -4 out the front. This has to, oh, yep, that was real dumb, wasn't it? -5. I have to reduce it by 1. So this becomes -5. Okay, let's see if we can remember some of the other ways that we write. Let's think about our indices. Give me another car.
Could be, this is from a skill check.
No, let's not do it like that.
Find something.
Okay, what would I do here? Okay, so I'm going to rewrite this exactly what Addie just said as a non-fraction, right? Sorry, -3. So I've got my -3, but then this is coming up and becoming a -2, so I can derive it. So what does my dy dx become? +6, because these cancel each other out. X minus 3, good. So if you have something that is on the bottom of a fraction, just use it as a negative power and do the same thing. All right, what if I have something like, let's do 5 root x. Okay, does anyone have an idea of what I should do with this? Ah, good. Y equals 5x to the power of half. I want you to remember all your fractional indices. So root x is x to the power of a half. What's the 4th root of x? X to the power of a quarter, right? So this is a square root, so we have a square. This is a 4th root, so we have a 4. So then what does this become? Dy dx is 5/2x to the power of? Yeah, -1/2. I need to now rewrite this, okay? So how could I rewrite this so it's a single thing with no negative powers? Careful.
5/2x. Yeah.
Okay, so this 5 stays on top and the 2 stays on the bottom. This goes on the bottom, and remember, to the power of half means square root. So I'm going to rewrite it like this. See what I'm doing? Same rule over and over again. Let's do something when there's more terms involved. No, because when I make, so remember, negative powers don't mean the number's negative, it means it belongs on the bottom of the fraction. So if I have x to the power of -1/2, that is 1/√x, right? Because this is 1/x to the power of +1/2 now that it's in the right place, which means root x. Okay, so it's not that the number's negative. That would be true if this was negative, then I'd say this, then I'd say this. Okay. All right, so let's also look at more terms. So what if I have x plus 3 squared for x minus 1? If I want to find the derivative of this, what would I do first? Yeah, I need to expand everything. So let's do this first set of brackets. What do we get? Good. Now I need to expand it again. So every term, right, goes on everything. So I get 4x squared cubed. Good. 4x cubed minus x squared plus 24x squared. Good. Minus 6x plus 36x minus 9. All right. Can we collect anything? What do we got? Okay, so then dy dx is 12x squared plus 46x plus 30. Excellent. So if you've got complicated stuff here, then expand it. The most complicated stuff is when you have negative powers. Let's do one where they're all fractions. So what if I have 2/3, actually, let's say 2, oh no, yeah. Leave me alone. 2 over 3x to the power of 4. Okay, let's rewrite this. What am I going to do? Okay, so I'm going to say this. Okay, does that look better? Or what Judah said, I could just do it like this. Okay, so then if I want to derive this, I've got a whole bunch of stuff going on here. What does my coefficient become? What does it become? It's negative 8/3, right? So I'm just times, because you think of this as 2/3 times negative 4 over 1, right? You multiply straight across top and bottom, which gives me this. And then x, what's my power? -5. I need to rearrange this. So how do I write it? Excellent. All right. So this is how would be how I rewrite that. Yeah. Yeah. Okay. That's pretty much it. We're just revising the tricky bits of deriving things so we can use them more. Now, oh, actually, sorry, there is one more quick thing I need to do. I think, do I need to do that? It's easy. It's stuff we've already done. I just want to make sure that. No, actually, we don't need to do it. Can someone just remind me? No, we don't need to do it today. What is the derivative? So if I give you y equals, it is not. It's the gradient. So the derivative here, this is the function. This is the equation of the gradient of this function. So because this is something like that, right? That is a positive quadratic. This gradient is constantly changing, right? What does the gradient measure? Steepness. So if we're measuring steepness and we do not have a linear equation, the steepness is constantly changing. So all we can ever do is find the gradient at a point. Remember we did that last year? If I want to know what is the gradient at 2, 3, can I do that with this information? What do I do? Substitute what? Okay, right. So in dy dx, I use my x and I say 6 times 2 plus 4, which is 16. So the gradient at this point is 16. So it would probably be up here somewhere, right? It's quite steep. Yes, it's the same thing. Yeah. So when the gradient is 0, what's happening on the graph? Turning point. Or what else is it called? It can be called that. Stationary point. A maximum or a minimum. Yep. So a stationary point is when the gradient is 0. Okay.